Hello, my name is JamariCleveland. Thank you for joining my presentation, and today I'm going to be talking about data at rest, in use, and in transit. So what is cryptography? Cryptography is the practice of encoding information so that only the intended recipient can read it, making the information unintelligible to anyone outside the conversation. And this conversation would require both parties to have a key for encrypting and decrypting the messages exchanged between them. An example of encryption we can see is plain text entering some type of encryption algorithm, becoming ciphertext where it's then transferred to a recipient and then decrypted at the recipient's side, which is being read in plain text at the end of the transaction. And three states of data on an information system are data at rest, data in use, and data in transit. Data at rest is any data that can be found in an information system storage, database, or file system. Data in use is data that's currently being manipulated, changed, accessed, or deleted, or observed by an information system. And data in transit is any data that's being moved from one place to another over a network, so in between two systems. All three forms of these data must be encrypted using either symmetric or asymmetric key encryption algorithms. Asymmetric encryption requires a public key and a private key pair, and they're used for encryption. Encryption would happen using the public key, which would be sent to the recipient for the recipient of the transaction to encrypt the message or whatever is being sent and send it back so that the sender could decrypt it using that same pair of private keys. So symmetric encryption, there is one private key that is held by both parties in the transaction, and they would use that same private key to encrypt and then to decrypt the message as it's being sent. Some asymmetric key methods are RSA, DSS, ECC, Diffie-Hellman, and TLS or SSL. Some symmetric key methods are DES, triple DES, AES, IDEA. The data security strategy changes vary with these three types of states for data. So we can see with data at rest, it's best to use symmetric key encryption. And this is because symmetric key encryption is faster, it requires less computational load, meaning that it requires less for a system to use the same key than it would to use a asymmetric key pair to encrypt and decrypt data. And it's best for file storage encryption because of this. An example is AES, which is Advanced Encryption Standard. Data in use is best used with symmetric key encryption as well. And this is because it's the faster of the two types of cryptography methods, which allows for temporary decryption of data and re-encryption after the data is done being manipulated, viewed, or whatever the case. And data in transit is best used with asymmetric encryption. It can be used with symmetric encryption. However, it is much more secure to use asymmetric encryption because it allows for identity verification, and it is also much more difficult to decipher asymmetric encryption over in a two-party interaction. So man-in-the-middle attacks are much less likely to occur. TLS is a example of a protocol that is used for asymmetric encryption.